Hi math students! This video is to help you with the Algebra 1B Unit 4 focus notes. So in this focus notes, we're going to be using this essential question. So make sure first of all that you have this printed off so you can fill it in as we go. And when you're done, you take a picture of it and submit that as your assignment. So our essential question, how can you identify the graph of a combined function? Remember, we don't actually answer this question here. This is just what we're thinking about as we go through this assignment. So how can you identify the graph of a combined function? Okay, the initial question, let's make that a little bit more specific. What happens when you combine functions? Again, we're not answering this question yet. We're just thinking about where could I find some information about this? So our source or sources. So usually your first source would be your course, the lesson. What lesson was this? So if I go back to the course here, so in workbook 17.2, this is when it talks about multiplying functions or combining functions. So I'm going to write workbook 17.2. And that's where I'm going to find a lot of information that's going to be helpful for me. You can also search the internet for information about this as well, but we have so much information in the course that might be the only thing you need. All right, some key academic vocabulary that we're going to be using in this assignment. So function, and we've done this before on previous focus notes, but function, what I want you to write for this definition is this: f of x equals something. This is our function notation. This is what you're going to see, and then what we're going to do is combine functions for this assignment. So for this definition, I just want you to write f of x. Just remember that this is what a function is. This is function notation, and you can put something after it if you want, like f of x equals 3x plus 2. I'm just making this up, but this is our function notation. So a combined function is going to look a little different. Actually, let's add one more thing up here to the function. Let's also do g of x equals, and just how about 7x minus 5. So it doesn't have to be an F. It could also be a G. You could really use any letter you want, but it's this notation with the X in parentheses that makes it a function notation. So now for the combined function, this is where we multiply two functions together. Again, you can find all of this information in this lesson. If you want to scroll back through, you've already done this lesson. So here's f of x and g of x. We're about to get to this combined function here. But you can look through here and make up your own definitions if you want, or you can just follow along with the definitions that I'm writing down. So combined function, if I want to multiply these two things together, so if I wanted to do f of x times g of x, we don't actually write it like that. The way we write it is like this. And I'll show you this back here on this lesson too. So this is what this had. We put the f times g in parentheses and then the x in parentheses. So it ends up looking like this: f times g of x. So this is how we write a combined function, this way right here. So whenever you see that, it means you're multiplying f of x and g of x. You're multiplying those two things together. So that's what a combined function looks like. And our other word here, quadratic function. So you've been working with quadratics in the last few lessons. So quadratic means that you're going to have an x squared in your function. And again, you can scroll through, oops, there you go, this lesson right here, and you'll see all sorts of quadratics. I think probably in the previous lessons is where it actually gives you the definition for quadratic function. But hopefully you're familiar with that by this point because we have been working with quadratics for a while. So quadratics means that it has an x squared. The graph would end up looking like a parabola. You should have seen some of these graphs now. It could be the other way as well. So that's what the graphs end up looking like. Okay, so now moving on to an example, number 5. So this is just the applying what you know. We're not going to solve the entire problem yet. We're just going to do part of it, or whatever it asks us to do here. So they gave us an f of x, a g of x, and an s of x. So here's 3 functions. And what they want to know is, what is the result of combining these functions? So this one wants to know f of g of x. That's how you say that, f of g of x, or f times g of x. So we need to multiply together the f of x and the g of x. Okay, so down here I'm going to do that. I'm going to do 3x minus 8 times negative 2x plus 5. So to do this, you should be using FOIL, and it says that again here in the lesson. If you forgot what FOIL is, right here, first, outer, inner, last. It's just the way that we distribute when we have two things that are being multiplied together that each have two terms. So hopefully you're familiar with FOIL here. So we're going to go 3x times negative 2x. So that's negative 6x squared. 3x times a positive 5 would be a positive 15x. And negative 8 times negative 2x would be positive 16x. Negative 8 times positive 5 is minus 40. And then you can usually combine these two in the middle because they have the same, they both have just an x, so I can combine those like terms. So negative 6x plus, what's that going to be, 31x minus 40. So that is what happens when I combine f of x and g of x. I get this right here. So same thing over here. They want you to combine, this time g and s of x. Okay, so I need to multiply g of x times s of x. So I'm going to do the same thing here. Negative 2x plus 5. And I'm going to multiply that times 4x squared minus 9x plus 2. If ever I'm going too fast, remember, you can just pause the video and take your time to write these things down. So negative 2x times 4x squared equals negative 8x to the third. Negative 2x times negative 9x would be a positive 18x squared. Negative 2x times positive 2 would be minus 4x. Now I'm moving on to the 5. 5 times 4x squared is 20x squared. 5 times minus 9x is negative 45x. And 5 times a positive 2 is a plus 10. I can barely fit it on my paper. So I know I have some like terms to combine. This is the only x cubed term, so I'm going to keep that, negative 8x cubed. I have a positive 18x squared and a positive 20x squared, so that is plus 38x squared. And then I have a negative 4x and a negative 45x, so that's a negative 49x. And I have that plus 10 on the end. So that's what I get when I combine g and s of x. So now number 6. This is going to be very similar. Let's see if I can get this to show. Remember, number 6 is always the same problem that we just did on number 5, but it asks you to take it one step further. What would the graph look like for the combined function? So we just figured out what the combined function was. Now, what will the graph look like? So this is what you learned in the lesson. If we have an x squared, this graph is going to look like a parabola. Okay, it's going to look like an x squared function. And you can use, I'm going to show you this. Desmos.com is a really great resource if you're trying to graph things. So Desmos, oops, Desmos. When you first get to Desmos, it always shows this, all of these functions, so it can be kind of confusing. You want to just start a new blank graph. And let's just type in that function that we have right there, negative 6x squared. And whenever you need, where is it? Somewhere you can add like an x squared. Oh, there it is. So squared, negative 6x squared, we had plus 31x and minus 40. And then you have that graphed right there for you. Here it is, and you can zoom out or in, whatever you need to do. That's the parabola right there. So if you want, you can just take a screenshot of this and include it, or you can just sketch that onto your paper right now. What will this graph look like? Well, there it is. So go ahead and pause the video and do that for a minute. Then you can also type in the second one that we did, the one that was an x cubed. So we had right here, negative 8x cubed plus 38x squared. I'm going to type all of that into Desmos, and I'll see what it looks like. So negative 8x, and I'm going to get this little keyboard so I can have an x cubed plus 38x squared minus 49x plus 10. So when you have an x cubed function, it looks like this. It's kind of cool. It's this shape right here. This is a cubic graph. So you can sketch that right now on your paper. You could take a screenshot of this screen right here if you want. But the question asks you, what will the graph look like for this? Well, it'll look like what we just showed on that screen. Okay, so now you are going to do the following problems. So it's going to be just like the ones that we just did. So here you should have some sort of graph sketched better than what I'm sketching, but I just want to make sure you have an answer in there. Now you're going to solve these two. We have s times f. So take a minute. You're going to take s and multiply it by f and get your answer down here. And then the question actually says, what would the graph look like? So you might want to type it into Desmos, or maybe you know what the graph's going to look like based on the previous answers up here. Here, what would the graph look like for g times f of x? And you don't have to be super specific. You can say whether it's going to be a parabola or if it's going to look like a cubic graph, a cubic function over here. So sometimes people can tell without even doing all of the multiplication. So s of f. So if I'm doing this one times this one, I know I'm multiplying an x squared times an x. So think about what x squared times x is going to give you. You might be able to answer this question, what would the graph look like, right, just off of that. Do you think it's going to be an x squared function or an x cubed function? Same thing over here, you're doing g times f. So I'm doing a 2x times a 3x. What's that result going to be? Is that going to be an x squared function or an x cubed function? So take a minute, pause the video, and answer those questions there. And last, we always do this at the end of these focus notes, your reflection, your summary. So we're answering that initial question way back from the very beginning of the focus notes. How can you identify the graph of a combined function? So how can you know what the combined function is going to look like just by looking at the functions? So take a minute and answer that. Maybe you want to say you figure out what the product is, or you do the multiplication and you look at the exponent of that variable to determine what the graph's going to look like. So for example, this one, I know it's going to end up being an x cubed. So that means I know that my answer is going to be a cubic function if the graph's going to look like this. Over here, I know when I multiply these two together that I'm going to have an x squared. So I know that my answer is going to look like a parabola. Okay, so take a minute and answer that question. How can you identify the graph of a combined function? So pause the video and write down some combination of what I just said or your own idea. And then how can this knowledge be applied in solving future problems involving graphing? So knowing what a graph's going to look like before you graph it is really helpful. Also, you can tell if you've made a mistake, or you can find answers more quickly because you know what that graph's going to look like in your head. You can also say that using Desmos.com, the online graphing calculator, is very helpful in solving future problems, and that you've learned that in this video. So go ahead and take a picture of this and submit that when you're done writing all of your answers.